All right, good afternoon, my wonderful viewers. Here is your chemistry teacher, Folajimi Akinpele. We are taking another dimension now, and that dimension involves carbon and its compound. Just watch as we continue to explain this carbon and its compound. It's an SS1 third term topic. Just join me as we continue. Now, carbon and its compound. Next slide. Carbon, being at the center of the second period, shows very little tendency to acquire 4 electrons and become carbon anion, or lose 4 electrons to become cation. Rather, it forms 4 covalent bonds. Invariably, what I'm explaining here is that if you draw carbon, the atomic number is 6. K shell has 2 electrons. The L shell has 4 electrons. So carbon is a tetravalent element. It has 4 electrons. It cannot give the 4 electrons. If it gives, that is when it becomes positive. If it accepts, that's when it becomes negative. When it accepts, it becomes negative. And negatively charged ions are called anion, just as you can see here. Positively charged ions are called cation, just as you can also see there. So carbon does not give, neither does it really accept, because it has 4 valence electrons in the atmosphere. So what it does is that it goes on into covalent bonding. Carbon exhibits in free and combined state. It is odorless, tasteless, with high melting point of about 3,500 and insoluble in common solvent like water, like petrol. You can see that. It is capable of forming single bond with itself, with other elements. It's also capable of forming multiple bonds. Ability of carbon to combine with itself is called catenation. Waik Jam Neko can ask you this in form of question. Catenation is the ability of carbon to bound with itself in forming a chain. This is responsible for numerous compounds. Now, allotropy. What's the definition of allotropy? Allotropy is a phenomenon whereby an element exhibits in 2 or more various forms in the same physical state. 2 or more various forms in the same physical state. Please, you can take note of that. Allotropes of carbon. Carbon exhibits allotropy, and the allotropes, 2 major, are diamond and graphite, are the 2 allotropic form of crystalline carbon. So obviously carbon can be divided into amorphous and crystalline. So the crystalline carbon has 2 allotropes, which are graphite and diamond. The non-crystalline carbon is otherwise called amorphous carbon. And these are, you can see, number 1 is coal, number 2 is coke, number 3 is charcoal, number 4 is sugar charcoal, number 5 is lamp black, and number 6 is carbon black. So as students now, few questions you can ask yourself will be, what are the allotropes of carbon? The crystalline allotropes, the amorphous or non-crystalline allotropes? What are the examples of non-crystalline allotropes? Answer these questions and get sure that you understand them. If you don't still understand them, you can still watch this YouTube video again. So let's continue.